All right, here we are with graphing radicals, day 2. And hopefully this assignment will go even faster than day 1 if you kind of got the idea of it. And so graphing a radical. So always remember that the parent function is at 0, 0, 1, 1 and over 4 up 2. And so for this particular graph, so that means that if we're going to do negative, we'd actually flip it upside down, right? So we'd go ahead and flip and make it upside down. And so then it would come down there just like that. And so there's your graph for number 1. The domain is the x values. So x equals 0, 1, 2, 3, 4, 5, 6, all the way to infinity. So we would say the domain is x equals 0 to infinity. And another way to write that you'll see on the multiple choice part of the test is all numbers x, so all numbers x greater than or equal to start at 0. So that means all numbers greater than or equal to 0. So including 0 and then all numbers greater than that all the way up to infinity. Okay? So then the range, in this case, the range would then be the y values, right? So y equals 0 is where we start. So we do start at 0, including the 0. That's why we put a bracket around it. And then negative 1, negative 2, negative 3, negative 4. Eventually, it's going to take a lot longer, but eventually we'll get to negative infinity. So from 0 to negative infinity. Now another student was asking me, like, well, can't we go from bottom to top? So I guess technically we probably should put negative infinity to 0, technically, huh? And so I've already made a mistake there. Can you see my mistake? Yeah, it should be a parentheses around the negative infinity. Yeah, so we'll probably do, that's probably the better range to do, good. Or you could say y is all real numbers, so less than or equal to 0. Because that would mean 0 or negative 1 or negative 2 all the way to negative infinity. Cool. So that's how you do these type of problems. We'll do a few more to help you there, and maybe a mixed review too. Let's see how much time we have here. So this one is going to be a shift. Ooh, a lot of shifting here, isn't it? So starting at 0, 0, this means to go up 5, and this is the opposite. Inside the house is the opposite. And so it means instead of going to the right one, you're actually going to go to the left one. So we're going to go to the left one and up 1, 2, 3, 4, 5. And we're going to go down. So we're going to go down, but we're also going to go down 2. So instead of 1, 1, like we're used to doing an upside down radical, we're going to go down 2, like that. And then when we go 1, 2, 3, 4, instead of going down 2, we're going to do 2 times 2 is 4, yeah. So it's going to go like that. And so that'll be our graph. The domain will be starting at our x value, which is negative 1, right here, and then going to infinity to the right there. So we're going to go ahead and do negative 1, including the negative 1 to infinity. And then the range will be starting at 5 and then going downward. So negative infinity and then all the way up to 5. Or you could put y is less than or equal to 5, because it's less than 5 or equal to 5. Cool. So see, these aren't too bad. Let's maybe jump to maybe a trickier one. What do you think? Boop, 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 boop. Should we do a fraction? Maybe an upside down one? Ooh, a cube root. That's going to be intense. So a cube root, if you don't have a graphing calculator, you're going to have to do an xy table is what you'll have to do. And you have to choose values for x very carefully. And you have to choose values for x that inside there that's either like a 0 or a 1 or a negative 1 or an 8 or a negative 8. And the reason why that we choose those is because we know that you could put that those are perfect cube roots. So in this case, we would have 0, and that just becomes 0, and then 0 times negative 2/5 is still 0. So we will start our graph off at 0, 0. Then we plug a 1 in there for x, It's going to be 1 times negative 2/5 is negative 2/5. Then when we plug in a negative 1, it'll be negative times a negative, so positive 2/5. Then we plug an 8 in, so the cube root of 8 is 2 times 2 times 2 is 8. And so one of those 2's will come out. So the cube root of 8 is just equal to 2. Cool. So then we have 2, and so 2 times 2 is 4, so we have negative 4/5. And then when we plug in the negative 1, we'll get a positive 4/5. Cool. So over 1, and then we go, let's see here, so 0, 0, and then over 1 down negative 2/5, which is like right there. And then back 1 up 2/5. And then over 8, 7, 8. And then down almost to 1, negative 4/5. And then the back 8 up there. So this one's going to be very thin, very, very thin, just going up this way and just going up this way. Okay? Maybe make that a little bit straighter. Cool. And so that'll be that graph. So the domain is nice and easy. So it'll be x equals all real numbers and y equals all real numbers, because it will eventually get to infinity with y going upwards and downwards, but it's just going to take a long time. So eventually these y values, it's almost to 1. It's at negative 4/5 at 8. It's going to do, so at, sorry, that's over here, negative 4/5. Over here is positive 4/5, which is almost 1. So eventually you will get to 1, and then a 2, and then a 3, but it's going to take you a long time. It's going to take you a really long time to get there. So, but it is eventually, you are going to go up eventually and down eventually. It's just going to take you a long time to get there. So it's negative infinity to positive infinity. If you want to put it that way too, you can. Cool. So that's how you do that one. So that's how you do the cubes. That's not too bad. Not too bad there. So you can also use the graphing calculator. If you're not sure where cube root is, then it's under the math button, option 3. So if you go over here to the cube root, it's going to be, so push y equals like that. You can go to the math button, and then cube root is number 4 there, cube root. And so in this case, we're going to do the cube root of x, but we also want to put a 3 in front of it. So we got 3 times the cube root of x. So then we'll graph that sucker. So it looks like it's expanded down and then goes up. So very similar to square root, but it's got a tail that goes the other direction. Cool. So that means that, let's see here, we can push the trace button. So we have at 0, 0 is where it is. This is kind of faster than choosing points, huh? In fact, you go to second table, that's actually going to give you the whole numbers, and that would be cool. So at 8, we get the number 6. So over 8, and then up to 6 is right about there. So it's going to go, did we get another point before that? There was a whole number or no? Not really. Oh, 1, 3. There you go, 0, 0, and 1, 3. So over 1, up 3 would be good enough. Just like that. But if you want to continue it, there you go. And then going back 1, down 3. And so it's going to go like that, and then continue that way. Cool. So there's the graph for a full point there. And then again, the domain and range is all real numbers, always for cube roots, because you can plug in any number and you'll get any number back. And even if you plug a negative number in, a negative number comes out. All right, so there's that. And then here we go. So then these ones is back to solving rational equations. Remember how to do that? So we'll help you with number 15 there. So a 2 and a 3, a k squared and a k squared. So we want the bottom denominator to be the same, and 2 to become a 3. What? 2 can't become a 3. Well, what can it become that's like 3? A 6. Nice, Maddie. So then that could become a 6. That could become a 6. Oh, we don't want to do the third time because Shane Jones definitely hates that. So then, but we do need that to become a 6. So we could just multiply it by 6 up there in disguise, hiding with the k squared, 6k squared. Let's see here. Yeah, oh, that needs a k squared. So if we times it by k, now all of them are k squared. Nice. Trying to get the common denominator. Whoa. Trying to get the common denominator there on all of them. Yeah, this one, top and bottom. Oh. Oh yeah, times it by 3, because if we times it by 3, that'll make it a 6. And so times it by that, top and bottom. This one, to make this a 6, we times it by 2, top and bottom. And so now we have 6k squared, 6k squared, 6k squared. So we cross out the bottom and just solve the top. So 3 times 1 is 3, minus 2 times 2 is 4k, equals 6. And then, what do we do next? That's right, minus the 3 to both sides. So then we get negative 4k is equal to 3. And then to finish off this problem, close, yeah. Yeah, right now it's being times by 4. So then to undo multiplication, we divide it by 4 to both sides. So then k equals, yeah, or even negative 3/4, you could say. You can move the negative up if you wanted to. The negative could be there if you wanted to be. Yeah, woo! So negative 3/4 is the answer to 15. So do that same process, everybody watching this video. Do that same process for like 16, 17, and 18. I don't know. I'll come look in a second. Oh, that's strange. So then we have, so cross it out. So then we have 3 is equal to v minus 1. And then add 1 to the other side. And so then we just get v equals 4. Nice. And that would be correct, because 1/3 minus 1/12 is 1/4. Cool. Oh.